Introduction to Sine. You're going to be learning about the trigonometric function sine, and you'll also be learning about other trigonometric functions, but in this short video, we're going to be focusing on sine. It's important to know that since we're working with complementary angles and trig functions with right triangles, it's important to refresh your minds on what a complementary angle is. So when you have two angles, we'll say angle A, and then you have another angle, because we have a pair of angles. So this is angle B. Angle A plus angle B must equal 90 degrees. So when something is complementary, both angles, in the sense of angles, I should clarify, but when you have a complementary angles, that means two angles add up to 90 degrees here. So that's what complementary means. You have two angles, angle A and angle B in this case, and they add up to 90 degrees. They sum to 90 degrees. So now that we've got that out of the way, it's important to also know that any acute angles within a triangle are complementary. And what that means is if we have, say, a low right triangle here, remember an acute angle is less than 90 degrees. We know this is less than 90 degrees, so that's acute, and that's less than 90 degrees, so that's also acute. So if we take these two angles here, let's say this is angle A, and this is angle B, alright? Well, these two angles are acute. We know this is 90 degrees, so this can't be acute. It's just a 90-degree angle. It's a right angle. Well, we know these must add up to 90 degrees because we already have 90. All three angles must sum to 180. So if we do 180 minus 90, we're left with 90. And we're left with two angles. So these being acute means they're complementary because they both add up to 90. So I hope that clarifies something and maybe gives you guys a bit of information and insight on angles here. Now, let's introduce sine. So when you write on paper or whatever, sine, the function, is not denoted by this, but it's actually denoted by a little abbreviation that's just slightly shorter, just sin, as I like to remind myself. So sine is a trigonometric function, and the input isn't like a traditional input. The input to this function is an angle, and in math, we typically use the Greek letter theta, or sometimes pronounced theta. We use this Greek letter to denote a unknown angle. And what that just means is that we just don't know the angle. So if I have like a triangle, if you were presented on a piece of paper, a little triangle here, and you had these little angles here, and let's say we knew this angle because that's 90 degrees, it's a right triangle, and then we didn't know this angle, we could say that's theta, right? And I would say this is 30 degrees, that's most likely not. But in this case, we would know this is 60 because if you just did the math, 90 plus 30, 120, 120, or 180 minus 120, it's 60. But in this case, we just don't know this, so it's unknown angle, and we just use theta typically. We can use any other letter or character, but we typically use theta, and it's just a universally known fact. So the sine function looks a little something like this. It's the opposite side, so I'm going to say opposite, and it's divided by the hypotenuse of the triangle. I could have done that a bit better. But what this means, if we were to visualize here, I can get a triangle here. So if we have a little triangle here, let's say we have this angle here. So we're going to visualize sine here. Let's say this is our 60-degree angle. Alright, we know this is the hypotenuse by default. To visualize sine, we're going to say sine of 60. So let's say the 60-degree angle is our input, so we're going to put 60. Now, sine of whatever angle is equal to the opposite side of the angle over the hypotenuse of the triangle. So what's the opposite side to this angle? Well, we know that this would be the adjacent, and it can't be this because this is the hypotenuse. So it must be this. And typically a way to remember this is just the opposite side is the side that isn't touching the angle in any way. Like, the opposite side would be the side that doesn't compose the angle. So this hypotenuse and this little side right here make and form the angle that we're getting the sine of. So these can't be the opposite. So this must be the opposite because this side here doesn't make up the angle that we're getting the sine of. So let's say this side is x, and then we'll say the hypotenuse is, well, we'll just say h. In this case, it would just be x over h, and that's what it would look like. Now, if we were to take a real-world example, or not really a real-world example, but if we were to do it with real numbers here, let's say we have our little fun triangle here, and I seem to love 30, 60, 90 triangles here, but we'll use one again. So we have 60 degrees, 30 degrees, and let's say this is 12, this is 11, and then we'll say this is 6. This wouldn't be 11. If you remember, this would actually have to be, this would actually have to be 6 root 3. Let me do that 6 a bit better. If you remember from the previous videos, this should be 6 root 3 due to right triangle trig and the side ratios. So, in this case, if we were to get the sine of 30, right, so sine of 30 degrees, right, according to this, well, this would be equal to the opposite, which in this case it's 6, because we know that this side right here and this make up the angle, and when it comes to sine, the opposite side doesn't make up the angle. So in this case, we can just know that this is 6. The opposite is 6. And then 12 is the hypotenuse, so 6 over 12. So the sine of 30 would just be 6 over 12, which in fact, if you do this in any calculator, the sine of 30 is equal to 0.5. Which we can tell here because 6 over 12, that simplifies to 1 over 2, which simplifies to 0.5. So we know that the sine of 30 is 0.5. Now, what if we wanted to get the sine of 60 here? Let me do that. So let's say we wanted to get the sine of 60, right? Well, the sine of 60 in this case would be the opposite side, which is 6 root 3. And then we're going to divide by the hypotenuse, which is always going to be 12 in this instance, just for this triangle. Don't take that literally for every triangle. But in this instance, it's going to be 12. And then this right here is our answer here. And obviously, you can plug this in calculator and get a decimal. I don't know the decimal right now, but that's what sine is. So it's important to remember that sine is a function where the input, right, the input is an angle. All right, so the input is an angle, and it's equal to the opposite side over the hypotenuse of the triangle. So remember, the angles, unknown angles, are denoted by theta, which is a Greek letter. Looks like a little 0 or a big circle with a line through it, typically. And remember, sine is just equal to the opposite side over the hypotenuse side of the triangle. And that is the introduction to sine.